Hello, everyone. How are we all doing today? Yes, we are back to our lovely, wonderful sessions. And today, of course, we've been dealing with a lot of AI series. We would also be following up with another interesting topic on AI and how to make use of your Azure AI agents, AI Foundry, and all of your possible Azure AI resources. With me in the studio today is one of our senior MVPs and also a community leader who has, been in the forefront of leadership in the Azure community in Nigeria. And of course, he has quite a number of years of experience with over 11 years in the IT space. He's an experienced architect with expertise in cloud and on premises, right? He also, with his extensive experience, he's able to design and implement workloads across the private and public hybrid cloud solutions. I know you know him already, but it's always good to give honor to whom honor is due. He's currently a senior technical architect at KPMG, and he more is focused on developing cutting edge cloud solutions. So, yeah, our MVP for today is none other than Imo Etuk, and he's going to be talking on a wonderful, wonderful topic. But before I proceed, I think it would be nice to also introduce myself. In case you haven't or you don't know who I am, my name is Promise Uche Unwachku, and I'm also an MVP for Microsoft and also a community leader as well in the Azure Nigeria community, right? Imo is one of our wonderful leaders, like I mentioned, and he is also going to be leading this interesting session for today. Hello, Imo. How are you doing?
I promise. Thank you very much for having me. Thank you for the wonderful introduction.
Yes, yes,
I'm
yes,
glad.
yes, yes, yes.
Okay, so
Um,
it's
I guess
nice being
we're
here
going
today
to be
again.
listening to some wonderful session for today. What have you
Yeah,
got for us today?
I brought before you building multimodal AI, multi-agent AI systems. Of course, we are going to utilize Azure AI services for this.
Awesome, awesome, awesome.
So the audience, I hope you are all set today to learn one or two things on the topic on the screen. And if you, in case you don't know, this series is part of our this section is part of the series that we started. I think promise. I think few weeks ago or a month ago.
Yeah, I think we started
So
in the month of May.
yeah. So and it's still ongoing.
Yeah,
We are yet for you. We are yet to bring you up to speed in terms of AI services that is provided by Microsoft. And today is just one of the sections,
yeah.
plus numerous ones that are coming up from next week. So
Awesome.
without much ado, I will move down to what we have on the screen. And like I always advise, we are here to learn. Sections like this are meant for learning because it's not just the speaker that will be presenting. It is meant for to be interactive, and also everybody should be involved and also learn along. So, just as promised, I said, my name is Imoetuk. I'm a Microsoft MVP, focusing on cloud computing, and I also do a bit of on-premises and DevOps as well. Then the AI now. So let's move down. We have some agenda on the screen which we are going to speak to, and we are going to run through the introduction. We're also going to get to understand what multimodal models, multi-agent AI services, AI system is. Multi-agent is. Then we're also going to be looking at the differences. between single agent and multi agent architectures. So at the end of the day, we are going to dive into building content processing solution accelerator and multi-agent custom automation engine accelerator. So those are the two things on the screen. So now we all know how AI is changing the landscape when it comes to the way we operate and the way we work. And now, when compare a multimodal agent system or multi-agent system to single agent system, we understand that single agent system has autonomous. It stands alone. It's a standalone agent. But multimodal agent has multiple autonomous agents that interact within a shared environment. And when you just like building a microservices system whereby you have multiple containers and pods that interact that helps handle each of the components of your application. So multi-agent system can be likened to such an architecture setup. So now, when we have because we have multiple autonomous agents interacting with one another, they can collaborate. These agents can talk to each other on by themselves. They don't need you to be there before they can talk. So they can interact, collaborate, and even negotiate, or even compete with each other to achieve individual collective objectives for you. For instance, if you maybe in a smart manufacturing setup now, various robot, in this case agent, might be working together on an assembly line just to make sure that each of the components of the task are handled at the same time, and at the end of the day, the desired result is achieved. So that is what a multimodal agent or multi-agent AI system is. If you have questions, feel free to drop them in the chat, and the moderator will bring it to my attention. So we move down to the next one. We're talking about differences, the distinction between the single agent, this in terms of interaction dynamics. Like I mentioned before, single agent systems operate independently without the need for communication protocols. In contrast, multi-agent system requires sophisticated mechanism to be set in place for the agent to interact effectively, ensuring robust coordination and conflict resolution between agents. So now, like if you just like you having one single system in place, in the other way in the system world, in the maybe we call that like the monolithic architecture, whereby you have a coupled system together, the system but that are not decoupled. That's exactly what single agent system are. Then we have in terms of complexity and scalability. While single agent systems are generally simpler to design and implement, they may struggle with complex or large scale problems. Meanwhile, for Mars, that is multi-agent system, it offers us scalability by distributing tasks among agents, enhancing the system's ability to handle intricate challenges or even downtime as well. So, in the area of robustness and fault tolerance, so now multi-agent systems are designed with a fault tolerance and in place, like failover and all. They are well decentralized. They are well decentralized and they contribute to greater resilience. We all know that when you are building systems, you should have it at
Hi, Bo. Hello, Imo. We cannot hear you. Your audio.
Hi, Mo.
All right. I think we are having some audio connectivity issues from Imo. I guess he'll be joining us soon. Um, while he tries to fix the audio. But of course, the topic we are actually focusing on today is quite an interesting one, and it's basically dealing with multi-agent systems. Of course, with the introduction of the Azure AI services and the agentic AI season which we are in now, you have a lot to do with agents. So, how do you make use of these agents? How do you interact with these agents? How does the agent help you to execute services? Those are things I think that you need to understand, and that's what our MVP Imo is here to provide context into. Um, One of the things you want to understand when it comes to multi agents is the fact that these agents, right, can help you automate tasks. I would say to ease the what's the word now, to ease the stress of repeating tasks every day. One of the things these agents can help you do is to create a seamless process that would help with with let's say configuring the task. So I mean, you might be in situations where you're wondering, oh, how do I work with how do I simulate events like this, or how do I simulate services like this, right? Yes, these agents can always help you do so, right? I think that is one beautiful thing about them. Right. Um, I don't know if Imo is back. Imo, are you back? Yeah, looks like we still have the audio issue. I don't know. Are you able to hear me? Let me check on with him. So Imo is going to be fixing his audio, and we are going to be proceeding with the session. So just like I was saying, right, multi agents are here to stay. They are not going anywhere, and of course, you need to be able to understand how to deal with these agents or how to work with these agents, right? And one of the very few things you will notice when it comes to agents like this is the fact that Well, of course, there are some configurations you have to do, some simulations that come into place that you have to work with. So, firstly, you just need to have an understanding on how the some of the concept around this agent, the best practices, what are the best way to generate your text, sound, images using some of the models like GPT-4.0 Mini, DAL-E, GPT-4.0 Real Time, right? So, I mean, these are some of the things we'll be focusing on in this session. And of course, we want to demystify multimodal systems and how they function and their, of course, their capabilities. That is one thing we want to be able to do in this session. Um, yes. Give me a second while I sync with Emo. Back.
Hi, Promise. Can you hear me?
Awesome, I can hear you now. That's good.
Honestly, apologies.
Yes, I know this happens sometimes. This happens sometimes.
So, okay.
So I was just running them a bit on the, what will I say, the workshop. But of course, you can continue from the part where you were speaking about how the models communicate with one another and the various type of models that we currently have, and how the multimodal systems work hand in hand. So I guess I will be handing the stage over to you then.
Okay, so I'm back now. I will share my screen in a bit.
Awesome, please.
And
Please,
then
please do
share.
so.
Okay, just a minute.
Yes.
Okay, so sharing this now. Uh, smile this screen. Okay. Okay. I think my screen is visible right now.
Yes, it's readable.
All right. Apologies for that interruption, audience. Let's continue. Promise has already done some good stuff. Thank you very much for standing in for me. So I we were speaking to the distinctions between a single agent and multi-agent system. So continuing from where we stopped, I spoke about. Okay, let me start afresh because I think the audio didn't even allow us to hear me. So we all understand how the microservices system work, where you have a decoupled systems. The whole systems are not coupled into a single system. So that's the way multi-agent system operates or function. In multi-agent system or multimodal agent system, we have multiple agents that interact, that handles tasks on your behalf at the same time. So it's not like a standalone model or agent where you have in the situation for single agents. So these agents can handle tasks autonomously on your behalf. They can interact with each other to help you achieve your goal or accomplish your tasks within a short minute of time. So now, if you have a scenario where back then in economics, for those of you that are economics student, we all know what is called a division of labor. So whereby if you have a task, of course, that task is going to be shared across multiple teams, a number of teams. So each person will take on what he or she specializes on and function and deliver the part that's meant for them to deliver. So that same way, and of course, let's assume you work in a place where you have to divide your tasks. When you divide the tasks, you still have the room to interact with your colleagues to understand the point in which they are driving at. So multi-agent model or AI agent also have this ability. Each of these agents that are forming part of the system also have the opportunity to interact with each other and even compete with each other to complete the task that you give them. So it's as simple as that. So in contrast, we have the single agent system that consists of only a single entity that operate within an environment to achieve a specific goal. So the multi-agent is here to help us to achieve multiple tasks. So now we want to look at it specifically from their system flow, the design flow, how they're interacting. We look at the interaction dynamics between a single agent and multi-agent. Yeah, single agent, like I said before, operate independently without the need for communication protocols. While in Mars, that is a multi-agent system. It requires you to set up sophisticated mechanism for agents to interact effectively with each other. Now, this also ensure efficient coordination of tasks and also resolve conflicts within and among agents. We also will be looking at the complexity and scalability. Now, from the aspect of design, it is complex, more complex to design a multi-agent system or multimodal model or AI system as compared to just having a single system design. So, and also with its complexity, also comes with a high level of scalability that enables a multi agent system to distribute tasks among agents easily, thereby enhancing the system ability to handle some tasks that are challenging as compared to a single um, agent system. In terms of robustness and fault tolerance, when building multi-agent systems are built, AI agents are built with fault tolerance in mind, with reliability, high resiliency, as compared to the single system, which only a single point of failure is there, but we have multi points of failure when it comes to multi AI agent system. So you can see that while single agent lacks the redundancy, which make them to be vulnerable to failures, multi AI agent system can withstand failure, thereby increasing the performance of the system. So let's move down to another point. Okay, this is repetition. Okay, so like Promise said, this particular session isn't about slide presentation. It's about us getting diving into building a multimodal, multi-agent system, and we have about two solutions to work on, and which you are going to play part. If there's a guided links which you can scan the barcode, any of the solution you want to build. We have one to be build content processing solution accelerator. We also have one multi-agent custom automation engine solution accelerator. These are the two solutions that we're going to build. And then all what the instruction on how to build are right there in the GitHub link. So when if I believe you have scanned the code, or if you haven't scanned the code, I will drop the link in the chat. So let's, without wasting time, let's move down to the GitHub guided instruction page provided by Microsoft. So we have the content processing accelerator app. So if you scroll through this, we have the solution overview, which you have the time to read through, and it will be very helpful if you understand all the flow. So now we will move down to explaining this architecture diagram. Now, the architecture diagram is very robust, and it is what will enable you to understand how the application interact with each other, all the components of the application interact with each other. So let's move down to understanding the business case first of all. The business case here, let's see, business scenario is here because this is where what will determine your architecture design even before you dive in. So always pay attention to the business case. Here we have the business case to be a data analyst at a property insurance company manages and ensures claims for data accuracy and compliance. So what they face is that a recent natural disaster has led to an influx of insurance claims coming into the pipeline. So the analyst is tasked with accurately validating ingested data from claims and invoices being processed through the system. So this is the challenges and the tasks that are given to them. This is the task, this is the challenge. Challenge keyword here is a recent natural disaster that caused influx of that is a lot of incoming requests. So claims include various multimodal content types with details extracted and mapped to define schemas such as policy, plans, invoices, and insurance adjuster report. So now you are to use AI. AI is used to extract, transform, and flag potential discrepancies, such as missing policyholder details and outlier repair estimate. So the data analyst then cross-check the findings against historical claims, data, and regulatory guidelines. Collaborating with the compliance team, she verifies the flagged issues and refines the data set. So yeah, it is after you have understood the business requirement or the scenario stated there, you can then go ahead and come up with the architecture diagram. Here now, this architecture diagram, you can see the browser, that's the end user, uploading files. This file is being uploaded, that is the content. You send the content into the system to be processed. They will upload the content to be processed, and also monitor the process text through this. If you observe this, this is the monitoring pipeline. So, and this is the container orchestration engine that has like three apps, three containerized application. We have one to be content processor container app, and in this engine here, this particular app, what it does is to process the content retrieved from the queue storage. We have Azure queue storage right here. So once it retrieves the content, it connects to AI services, Azure AI services in this case, for extraction and mapping this content. Then it will also enrich the data before pushing to the storage or database. In this case, we have the storage queue. That is Azure Storage is the one that is being used for storage. Now, the second app, which is the content processor API, this handles the exposure of the API that interact with the file that is being uploaded by the client, and also handle job submissions by also enkeying them into the storage account. It also acts as the entry point. When the user upload, this is where this API handle the entry point and I set this file and enqueue them into the storage account, storage queue. So while the content processor web monitor a web app, what it does is provide real-time monitoring to the end user, showing the status of the processed file and all that, and also displays the historical data that the data analyst was meant to trace from the business case that we just read. So what the storage queue does is it receives the task from the client from the content API, decouples the producer API and consumers API. In this case, we have the processor worker and the processor API here. Producer, which is the API. So it also supports retries, scale out, and fault tolerance as well. So this one, all the models that are there in Azure AI Foundry or Azure AI Studio, which derives the functionalities. And so now in this place, for Azure OpenAI, we use Azure OpenAI in this case for mapping, summarization, and sentiment and analysis, and also classify the data based on GPT based on GPT reasoning. So in this other one, we also have the Azure AI content understanding. So this Azure AI content understanding helps to extract the structured information from unstructured content, and then also handles interaction like invoices, contracts, and PDFs, and also images that extract metadata. So in this case, we also have the blob storage, which at the end of the day stores the raw content of that is the result. All the result are stored in raw content. So Azure Cosmos DB, in this case, it enables querying of for all the previous job, and also support a real-time dashboard update for monitoring the web app. So these are the where this is the architecture diagram and the way it helps in achieving the goal of the data analyst. So now let's jump straight into the deployment guide, which is right here. You can just go straight to launching the deployment guide. And some of the prerequisites that you need to do is you can deploy this, but you need Azure subscription definitely, and also you need to note the regions where the services are available. This is very important, otherwise the deployment will fail because the models are not available in all the regions. So you can click it to see the regions and all that. So then these are the resources that are being used, and they are giving you links to the pricing pages. You also have the price to pay by Microsoft will charge you. So these are the models that are available, or Azure Open AI model that are there. So let's jump straight to the deployment guide. If you click here, it will take us to the deployment guide. These are the resources to be deployed. Now, there are many ways to do that. We will jump straight to deploying the solution locally. This is your local environment, that is your Visual Studio Code. GitHub code spaces will require subscription. Except you have it already. I'm not sure it's free. So you can also deploy in your VS Code using the dev containers. Yes, so you need to have your Docker installed and running. Let me start my own. That's remind me. Let me start my own Docker. So my Docker is starting. So now going through our local environment, one of the command that is very useful is AZD command. That is Azure Developer CLI. You need to have that installed on your system. So you can easily just install that by running a simple command like if you have a winget comes by default. If you're a Windows user, your winget come by default on your Windows system. So if you use winget install microsoft.acd, it will install the command for you. So I'm just increasing the font size of my Visual Studio Code so it can be visible to us. So now right here, I do not have any file. So I'm just going to minimize this. Go back to my Docker is up here. I'll minimize Docker first. So you are going to use this command to download all the project files to deploy. So you go to your Visual Studio Code. I've already, let's say, create a folder directory where you're going to be working from. Most importantly, yes. So go to, I think I have build. Now I have a folder here, directory. So I'm just going to run the terminal being by directly going into the directory where I want to deploy the app. So I'm just going to run the command acd um, acd init to download that code into my folder. So it will download all the deployment file from that GitHub repository. So all what you just need to do is follow the instructions. So here we have all the file, all the solutions have been customized in this place. So and anything you need here, the infrastructure part the bicep file has been written already. So all what you need to do is to do that. If it prompts you to install, you can install this. So now for the environment, for those of you who are not too familiar with the AZD, once it prompts you, the environment is going to be served, is going to serve as the resource group where the actual resources are going to be deployed into. So now I'm going to just type a unique name, call it um, RG content processor app. Let me just processor app. So now I have set my environment and it has been initialized. So now the next thing will be to deploy the app. If you follow the guided step using the SC, of course, you need to authenticate with your Azure environment, Azure subscription by using the AZD auth, or if you want to just be very specific, you can just use this command and specify your tenant ID straight away. So Let me clear my screen up. So you go through the normal SCD auth login command. It will open an interface where you sign into your account. So authentication is complete. It will retrieve the login. Now, when you are done, you run the SCD up command to deploy the app. Now, just still pay attention to the instruction given. In case you mix something, pay attention to the instruction. So the instruction says we have the up command, which I just ran. Provide the environment name, and if you want to bring down the app in a minute, just use the SCD down command, and the app will be deleted, will be taken down. So now let's go to this, select my subscription that I want to select. I can just keep it to be one subscription. So that is it. It will retrieve the region. Remember, when we were reading through, we were told some region that these resources are available. The East US was among the regions, so I'm going to just use that. So I'm going to just press enter. That's number line 48. Let's see. Running a prerequisite. So I'm getting some error here. Is my Docker not running? Missing requirement, Docker PA shows location, environment location, resource group. Okay, I'm coming. Let me go to my Microsoft Azure account environment to check something. So here, let's check the resource group. Um, okay, not here. So let's go back to the instruction. Maybe there is a step I mix, or let me authorize it using the tenant ID. So let's see if I will get the right. So go to this place again. I'll run the ACD up again. Or let's preview the solution, the file. Here we have the infra. We have images, Azure. Okay. So in this place, this environment, let me see what is mixing here. The resource group here, the the resource groups and everything are added to the environment variable, the environment file. Let me see the Docker file in particular. In deploy, app, this. Okay. Let me see if I build the app locally first and see. Docker build dash T content processing app. So let me see. Oh, sorry. There's supposed to be a dot in the front. Clear screen. So dot. Let's see if the app will build locally first. Unable to read the Docker file. So the problem is the Docker file. Couldn't read Docker file. No such file. Read file. Open Docker file. No such file. Okay, we are mine. Oh, right. I know why. I'm in the. I'm not in the root directory where the Docker file is. Let me go to dev container. So I'm here. Okay, let's see. So Docker build will build the app locally. So once it happen like that, after that we run it and see what happened. See if we can access it locally before attempting to deploy it to Azure. So it's very very large Docker file. So let's see. So while this is being built, if you have questions, let me know. So you can ask me. So let's even explore other option. This is the Docker container option that I'm using. If the local one doesn't go, you can actually try out the dev container deployment. Install Docker if not installed, then open it in your this. So once you do this, go to this one. Uh, if you are running Mac, these are also the instruction to use. Know that. So let's monitor this step. Okay. So it's still going. It's quite a large file. So on your own, you are going because we have two solutions to build, but because of our time, you are going to just do one. On your own, follow the guided step and try to deploy this. You can share your solution on the community WhatsApp group, or maybe tag me send to me on my LinkedIn, or tag us on our LinkedIn page, community LinkedIn page. So while that is still built, let's see. Okay, it's really a large uh, application file. So we're already in 4 by 4. So we are going to soon finish. So let me check what is my, okay. This is the name of my app. So just remaining one step to go. You're almost done. So this is our app, the latest one, the image there. There. Okay. So now, finally, we done building the apps. It's a very large one. So the steps, all the steps have been completed. So now let's go back to, let's check our Docker here and see the container. Okay, let's list the container that we have, running containers. Use the Docker ps command. None is running. Let's list all the containers and see. So, okay, let's see something. Let's just run the app and see if it will go through. The app name is use the Docker run in the dash mode dash p. We map it to port 8080 then 80. The container name is the same with the image name, content processing dash container. Then the image name is content processing dash app, the latest version of the image. So let's see, unable to find image locally. Okay, now let's see something. Let's run the ACD up and see. The image is not found locally. New field 10 file. Okay, let's go to, let's delete this file away. Delete that Azure HZD container app. So go back to the instruction and see what using dev container. Let me see something. Open, open in Visual Studio. Let me see if there's any special environment set up there for dev container.
Hello, Mo.
I promise.
Yeah.
My time is up. So let's see. I want to see. Got it. Okay. Go to a minute. Let me just see how this works. So connecting to dev container. Uh, okay. Without wasting our time, let's go back to the image is not appearing locally, and that is serious. Can't find it. Okay, it's here. I'm finding it here. Okay, container in use. Export. I found it under volume. Let me see build. Oh, this is the app here. Errors occurred. Okay. So actually the error needs time to for troubleshooting. But if you want to deploy the app, you can deploy it using the Azure CLI as well. If you scroll down to
Uh,
this does not have Azure CLI. Okay. So promise,
what
go
I was
ahead.
thinking was like, seeing as time is fast spent, maybe what we can do is we can share the guide to the community so that those who would like to take some time to go through what is here can try it out for themselves and have a first-hand idea of how to deploy these resources in their Azure subscription.
Yeah. Yes, sure. Okay, so you can try applying the step here on the other solution, this one, using the Azure CLI. I think Azure CLI will go straight than the ACD command. So you can try this at your spare time when you have the time.
Awesome, awesome,
Yeah.
awesome.
So
Um,
thank you very much for your time and thank you for joining. See you
awesome.
next week. If you have questions, don't feel free to send it across.
Feel
Thank
free
you.
to reach out. But I mean, I think it's been an awesome, amazing session. Imo, thank you for this sharing this knowledge on how to interact with multimodal systems. I think it was indeed a wonderful session. And also, just like we learned today about interacting with multimodal models and agents in Azure AI, we'll be also continuing session next week. So, what I would advise for everyone who took their time to attend this is to go through, just like has said, gain some first-hand idea or knowledge on how you can be able to build systems where the models and agents can interact with one another. Um,
I just
until
put the link in the short in the chat, the link to
awesome,
the GitHub exercise. So you
awesome,
can,
awesome.
yeah.
So, in case you haven't followed us on our channels, we would advise that you do so. Um, I mean, we have our sessions coming up from next week and upper week. We'll be discussing a lot about AI, Azure AI services. So I'll encourage you to ensure you are subscribed to our meetup page, because that's how you get the updates of some of these sessions we'll be having with you. At this point in time, I'd like to say thank you, everyone. Thank you, first of all, to MVP Imo for taking his time out to train us on this session. And also thank you to every one of you who took out time to listen and to learn from this session being taught by MVP Imo. At this point in time, I'd like
Thank
to say
you,
thank
Thomas.
you and see you next week. All right,
Thank you,
everyone.
Thomas. Bye bye, everybody. Bye.